Data loss can be aggravating, and one way we can keep it to a minimum is by applying RAID, or redundant array of inexpensive or independent disks or drives. But I don't fully understand what RAID is, and as a computer engineering student, I need to comprehend this data storage visualization technology for my upcoming finals exam, and to pass my subject in operating system. So, I interviewed IT experts and computer engineers from all around the country and all over the world, and I asked them about RAIDs. What are RAIDs? How do they generally work? I'm Abigail, and this is the different levels of RAID. The first that I interviewed was Professor Magistrado from Azure University.
RAID, or redundant array of independent disks, is a way of storing the same data in different places on multiple hard disks to protect data in case of failure with the drive. It works by placing data onto two or more disks and allowing input or output operations to overlap in a balanced way. This technique improves performance. Software RAID is a part of the OS or operating system and is the easiest and most effective implementation. Arrays act as a single logical hard disk appear to the operating system. With RAID, data is distributed across the drives is one of several ways, referred to as a RAID levels, depending on the required level of redundancy and performance. The different schemes or data distribution layouts are named by the word RAID followed by a number. For example, RAID 0 or RAID 1. Each scheme or RAID level provides a different balance among the key goals: reliability, availability, performance, and capacity. RAID levels greater than RAID 0 provide protection against unrecoverable sector read errors, as well as against failures of whole physical drives.
Now that we know what RAIDs are, another question pops up. Why use RAIDs in the first place?
It is highly functional. If dependability and data dismissal are important to you, your backups will not suffice. It is still a necessity to take the time to restore those backups, and those backups could be hours or days old, resulting in data loss. RAID allows you to survive a drive loss without data loss, in many cases without a downtime. If we think about the RAID 5, we can consider increased read speed and fault tolerance. So this RAID utilizes a combination of stripping and parity to achieve fault tolerance with improved read speeds. It requires a minimum of 3 drives to implement. So each drive in the array set aside a portion of itself for parity. In the event of a drive failure, the array will use the parity on the remaining drives to recover any data that was being stored in a failed drive. However, reading from the parity is slow, so there will be reduced performance until the problem drive has been replaced. So RAID 5s typically use as a mission-critical servers with some budget constraints when disk space is a priority. In order to prevent downtime in the event of a disk failure, it provides excellent read speed due to there being multiple drives available to you to access your data from, and will always retrieve your data from the quickest drive. So unfortunately, this write speeds are decreased when using software RAID, as the operating system will have to write all the data twice, once to each disk.
Not all of them are used equally. Some are used rarely. Let's take a look at the more used RAIDs and how they work.
RAID 0 is a popular disk or solid-state drive. This process spreads the data blocks across multiple storage devices, such as hard disks or solid-state drives. Unfortunately, the more stripes in a RAID 0, the more it has a likely chance to fail. RAID 0 does not only increase the speed, but also has the risk of loss of data. If you're gonna use this one, you're gonna make sure that you're gonna get your data lost in some way or another. RAID 1 is a popular disk or an SSD, solid state drive, that increases safety rather than speed by writing the same data on 2 or more drives. Unlike RAID 0, RAID 1 does not increase its performance. If one drive fails in a RAID 1, that drive manually replaced and then a second drive comes in. The downside to RAID 1 is its writing speed, because it works by mirroring to duplicate your data between 2 drives. When this process is being done, the disk speed decreases. The operating system will have to rewrite the data twice, but one by one. So RAID 1 is really a good RAID level for your uptime, and it's also good for web developers and good web servers also.
RAID 5 is currently one of the most commonly used RAID methods because it evenly balances weights and heights and is considered as the most secure RAID configuration. It has more usable storage than RAID 1 and RAID 0 configurations and provides performance equivalent to RAID 0. RAID 6 or double parity RAID is a type of RAID level that utilizes block level stripping and distributes 2 parity blocks on each disk within 3 arrays. It is considered an enhancement to RAID level 5 but adds parity block on each disk in the array. However, RAID 6 primarily has the ability to continue operations with it faces 2 concurrent disk failures. This is achieved through the dual parity block or RAID on RAID 6, providing enhanced fault tolerance and enabling RAID operations to continue even if encounters of a failure. RAID 6 write operations are slower than RAID 5 as it has to write an additional parity block, and it has configurations utilizes a minimum of 4 devices only.
RAID 10, as the name implies, is a combination of both RAID 1 and RAID 0. With the RAID 10 setup, you get the advantage of both RAID 1 and RAID 0 in a sense that you get the same data transfer speed with the RAID 0 setup, and you also get the fault tolerance that you would with the RAID 1 setup. The only disadvantage that you get with the RAID 10 setup is that you only get to use 50% of your memory. You only get to use half because half of that memory is being used to mirror the rest of the data like you would with the RAID 1 setup.
How about the lesser known RAIDs?
RAID 2 is another RAID standard level configuration that provides very high data transfer rate. A central controller synchronizes the disks by making them spin at the same angular orientation so that they will reach all index simultaneously. RAID 2 uses bit level striping rather than block level compared to the other RAIDs, and each sequential bit is placed on a different hard drive. The error correcting code used in the Hamming code party, which is calculated across bits and stored separately in at least a single drive.
RAID 3 also works as RAID 0. It uses byte level stripping, but it also uses an additional disk in the array. It used to store checksums, and it supports a special processor. In parity codes, calculating, so we may call it the parity disk. RAID 4 is very similar in RAID 3. It requires at least 3 disks for complete implementation and configuration. The main difference is the way of sharing data. RAID 4 is divided into blocks, 16, 32, 64, and 128 KB, and written on disk, similar to RAID 0. For each row of written data, any recorded block is written on a parity disk, which is not distributed. In short, this means the RAID 4 does not strip data at block levels, but it uses
byte levels for stripping. RAID 7, also referred as RAID Z3, it is a triple parity version, also referred as RAID 7. It requires at least 5 disks per VDEV and can withstand the failure of 3 of them.
Let us now recap. There are different levels of RAIDs, and there are 3 main RAID storage techniques. Of course, there are disadvantages when it comes to RAIDs, like how it doesn't make data recovery easier, how it cannot completely protect your data, how costly it sometimes is, and how it may slow down your system when you don't use it properly. But the benefits outweigh the disadvantages because RAIDs definitely provide higher data security. It really increases fault tolerance. It increases the parity check, regularly checks your system for any possible system crashes. Reading and writing data can be done simultaneously because of RAID. It improves availability and performance, and it attempts to ensure data reliability. I hope you've learned as much as I did. Thanks for watching.